Hi, my name is Erik Chu, and I'm an industrial engineering major at Cal Poly San Luis Obispo. My presentation will cover Supplier A's background information and their current production scheduling problems. Then I will discuss the design alternatives I developed, testing of the designs, results, impacts of the project. Finally, I will discuss the industrial engineering tools that led me to my conclusions and my final recommendations to Supplier A. Supplier A was opened with the vision to provide the best products to its customers in the aerospace industry. Supplier A's cycle time to manufacture products is very lengthy, and Supplier A also lacks the production system to accurately maintain WIP and inventory levels. Supplier A is being contracted by Company X that requires Supplier A to be efficient. Right now, Supplier A's production system is not lean enough to fulfill current and future business needs of Company X. The metric that I will be measuring Supplier A's performance is whether or not their deliveries to Company X is on time or not. I was part of Company X's team to ultimately audit Supplier A's supply chain and evaluate them as a supplier. The scope of the project will focus on Supplier A's assembly and manufacturing process, beginning with the order preparation process. Receiving delivers all the different tiny components needed to complete the manufacturing process. After that, supply chain analysts enter in the orders into the master production schedule in Oracle. On the shop floor, a group called kitting retrieves work orders from the master production schedule and prints the work order paperwork. Kitting then retrieves all the necessary components for assembly from the pickup area listed in the work order and waits for assembly to take over. Finally, a shop floor member from assembly takes the paperwork and begins the assembly process. This is the order preparation process. The issue that I noticed with Supplier A is with their production control system. When supply chain analysts push work out to the floor, the ERP system does not place a prioritization of work orders, so the shop floor would be working on orders due months ahead instead of work orders due right now. Supplier A's goal is to have a minimum of 3 weeks of orders on the shop floor and a maximum of 5 weeks of orders at any given time, but the ERP system does not differentiate work order due date. This leads to an influx of WIP in Supplier A's production system that leads to lengthy cycle times and ultimately late deliveries. This process flow map is the assembly process of Supplier A's different products. On the bottom right corner, there is a legend describing the symbols. The green boxes show the Kaizen bursts and areas of improvement I identified within Supplier A's process, and the letters depict Supplier A's different products that go through the assembly process. I learned firsthand how difficult it is in the aerospace industry to obtain any relevant data. Due to propriety and confidentiality reasons, the only data I was given was the processing times of the different workstations. I had to use assumptions for the rest of the project, including cycle times, assume Company X was the only customer, and assumptions about the economic analysis. I tested the alternatives by using a pro model simulation of the assembly process. Although the Cal Poly curriculum teaches a different software, I used ProModel at a previous internship and prefer it because of its increased capability and user-friendly interface. In the next slide, I will show a demonstration of the simulation. The simulation runs a total of 100 work orders. I created 100 different entities that represented work orders and ran them through the production process. Each entity had a starting and ending date, and based on their respective job scheduling technique, that was the order in which they entered the production process. The 100 work orders represents the demand of 1 month, and the simulation duration is 1 month as well. As a result, I created 5 different simulations. Simulations included first come first serve, shortest processing time, earliest due date, critical ratio, and critical ratio with line balancing. I also conducted a line balancing analysis to improve the assembly process efficiency. I only focused on manual operations instead of automated equipment. I calculated the number of workstations required by taking the total work content time divided by the cycle time. The results including adding 2 workstations for hand assembly and 3 workstations for soldering. Hand assembly is the workstation in which workers assemble the external components of the product with wires. Solder is the workstation in which workers meticulously paste solder joints onto the circuit board. Both processes are bottlenecks currently. The following is the results of the simulation. Since the problem statement refers to the issue of whether or not Supplier A was completing their custom orders on time, I wanted my simulation results to refer back to this issue and reference on-time deliveries. The first-come, first-served method is the most similar to the current process of supplier A because there is currently no prioritization of work orders on the shop floor. As a result, first-come, first-served will run whatever is in front of them. The results are clear. If supplier A utilizes the critical ratio while adding the number appropriate workstations to eliminate the production bottlenecks, then their on-time deliveries will increase substantially. I was able to develop two solutions for supplier A. The first design alternative is an Oracle ERP job scheduling. I chose Oracle because supplier A is familiar with Oracle and already utilizes it. All they would need to do is purchase and upgrade the job scheduling module available on Oracle's online store. This alternative also includes the implementation and construction of the additional workstations I calculated in my line balancing analysis. The second design alternative is an Excel spreadsheet that I developed that acts as an ERP system. The spreadsheet has three main functions: the ability to enter in additional work orders with necessary information such as job number, due date, arrival date, and processing time. There is also a critical ratio calculator to display what each work order's critical ratio is. Green means it is on time, yellow means it is currently on schedule, and red means that it is behind schedule and should alert the operator that the job needs to be placed on high priority and be run through the assembly process immediately. There is also a first-come, first-served calculator, earliest due date calculator, and shortest processing time calculator. Each of these are different job scheduling techniques that supplier A could implement in releasing its work orders to the production floor. The calculator will go through all the work orders and rank them so then the operator can decide which method to proceed with. Here is the economic impact of the two design alternatives. To start, use the simulation results multiplied by the price of each unit to get the yearly revenue. Second, I use the online resource Glassdoor to approximate employee wages. Lastly, I use the present worth formula for the two design alternatives. There is a statement investment cost for design alternative 1 due to the purchase of Oracle ERP software, longer employee training, construction of additional workstations for my line balancing analysis, and increased expenses such as electricity, labor, and maintenance. On the other hand, design alternative 2 requires minimal employee training and zero additional expenses. Supplier A is currently underperforming. That is why any improvement in how their work orders are processed will result in an immediate payback period. Since the final present worth values are nearly identical, then supplier A can choose the alternative that they want. On developing my design and finalizing my final recommendation, I had to consider any impacts it might have. The biggest impact it will have is on the employees at supplier A. The employees will need to be trained on how to use the Excel workbook and the additional Oracle ERP job scheduling module. Another additional impact is the transition from a paper system with printed work orders to an electronic system. I used many industrial engineering tools to come to my final recommendation. I used simulation, production planning, economic analysis, flow chart analysis, and line balancing skills to complete the project. This project was a good overview of all the skills that I learned at my time here at Cal Poly. My final recommendation to supplier A is to use the Excel workbook that I developed to adequately prepare for the construction and implementation of the additional workstations that I calculated for my line balancing analysis. There are many things to consider when adding infrastructure in a completed facility, such as building restraints, electrical concerns, and ergonomics for the users. This will take time. Moving forward, I recommend supplier A to transition to the Oracle ERP job scheduling module after the completion of the additional workstations, so that they will then have the same ERP system for receiving work orders and for releasing work as well. One ERP system creates a sense of continuity for the shop floor and will reduce any confusion. Thank you for your time.